Hi students, in this video we're going to see the orthographic projection in terms of projection of lines. So in the previous video I explained about the orthographic projection in point, that is the projection of points. So in this video we're going to see about the projection of lines. So coming on to the what do you mean by line? A line is nothing but the shortest distance between any 2 points is termed as a straight line. So when you're going to take a straight line, we're going to consider the two endpoints, that is starting point and ending point, as the representation, and I'm going to project that two endpoints to get the overall projection of your straight line. So the projector of a straight line is drawn, therefore by joining the projection of its endpoints. So what are the important things to be remembered is the true length, the apparent length, true inclination, and apparent inclination. So coming on to the possible projection of straight line with respect to VP and HP in the first quadrant. So now onwards, we're going to deal only with respect to the first quadrant. So when you're going to see the points, we're going to deal with all the four quadrants. Whereas when coming to the projection of lines, we're going to deal only with respect to the first quadrant, or we can say that we are going to deal with the first angle of projection. So coming on to the what are the different definitions I can give. One is the perpendicular to one plane and parallel to another. So I can define that as perpendicular to HP parallel to VP, or perpendicular to VP parallel to HP. The second condition will be parallel to both the planes, that is parallel to both HP and VP. The third one will be parallel to one plane and inclined to another. You can say that parallel to HP inclined to VP, or parallel to VP inclined to HP. The fourth one will be inclined to both the planes, that is inclined to HP as well as VP. So these are the four conditions based on which we don't have a problems. But the first three condition is only for the understanding sake, whereas the fourth condition is the one where you're going to solve the problems in the present semester. So let me take the first condition. So that is line perpendicular to HP and parallel to VP. So you can assume a line over there. Just I'm going to draw one more line. So I'm going to take the line over there, that is line AB. So I'm going to assume line AB. So line AB is perpendicular to horizontal plane and it is parallel to vertical plane. You can see over there. So when I'm going to observe from the front, so the line is already above HP in front of VP. So I'm going to observe the front. From the front, I can see what is the distance from HP to point A. So this distance I can observe, and I'm going to project B as well as A onto the vertical plane, and I'm going to join that, so that becomes the front view, and I can see the complete true length of the line over in the front view. So I'm going to draw a true length over this, that is nothing but the true length TL, and I'm going to specify B dash and A dash. So I'm going to observe from the top. This is a major thing, so I'm going to observe only the point B because A is exactly below B. I can't observe the A, so I'm going to write that one as B in bracket A. So bracket indicates it is an invisible point. So that will be projected onto HP, and we know that this will be rotated for 90 degrees. So when I'm going to rotate, so this is completely vertical, and you're going to join this connection. So this line should be a vertical, that is it should be in a straight line. So when I'm going to take this, the true length will be drawn over there, that is B dash to A dash, by taking the distance from HP. And when I'm going to draw the top view, I'm going to assume the distance from VP, and I'm going to draw the point. So normally what I'm going to do is I'm going to observe from the top, which will be the near thing, that is for the observe, which is the nearer point, that will be taken as a visible, which is away, that will be taken as invisible. So that I want to take as invisible over there. So this is when it is perpendicular to HP and parallel to VP. So coming to next one, line perpendicular to VP and parallel to HP. So when it is parallel, just observe now, the line AB are considered over there. So the line AB is parallel to HP and it is perpendicular to VP. So when I want to observe the front, I can see only the point B. I can't get the what is the length of the line. So what I have to do is I have to start my projection from the top view, where I can see the complete length of the line, that is AB, and I'm going to project that onto the horizontal plane to get the top view, that is A and B. Then I'm going to observe from the side front view. So I'm going to project that this will be projected onto B point. So that I'm going to specify as B dash in bracket A dash, because B is visible, which is near to the observer, and A will be invisible, that I'm going to draw in the bracket. So this top view will be drawn first. So I'm going to rotate that, so it becomes a vertical. So I'm going to draw that AB first, then I'm going to go for the top view. So I'm going to observe from here. Normally when you're going to do the construction in a two-dimensional view, so B will be near to the observer, that will be visible, and A will be away from the observer, that will be invisible, that has to be drawn in a bracket. So coming to the third one, so that third one is the very easiest one, where I can see the true length from both the sides, that is from the top view as well as from the front view, because the line AB is parallel to both HP and VP. So when I want to observe from the front, so A and B point will be projected onto vertical plane to get its front view, and I want to project B and A point onto the horizontal plane to get the top view. So when I want to join that, so I want to get the exact view of the things. When I want to rotate HP for 90 degrees, I want to get both the points and I want to get the view over here. And one more thing you have to remember, this is the end projector of point A and this is the end projector of point B. So the end projectors plays very important role in some of the problems where they want to define the end projectors for you for your reference, and you have to do the projection. So coming on to the fourth one, that is line inclined to VP and parallel to HP. So this is the one of the condition where you have to remember this when you are doing the problem. So when I want to take which is parallel and then I want to incline with respect to VP. So this is the inclination with respect to VP that I want to specify as pi. Okay, so you can see there, this is the inclination I want to get with respect to the VP. So when I want to observe from the front, I can see what is the length, but I can't justify that what exactly the length is, because when I want to project that, I want to project the endpoints parallelly, the size will be reduced with the actual size. If I assume the actual size is 50, the view size, when I want to observe from there, the size will be reduced and the view size will be somewhere 35 to 40. So that length will be reduced. That length is called as the apparent length. So remember, the true length is the actual length of the line. The apparent length is nothing but the view length when you want to observe from the front view or a top view. So from the front view, I can't see what is the exact dimension of the line and the angle. So I want to start with the top view now. So where I can see what is the actual angle inclination and what is the actual length will be drawn. Then I want to project that onto the front view to get the front view over there. Similarly here also I want to start with the top view first by taking the angle and the length. Then I want to project vertical upwards. So by knowing the distance from HP, I can draw the line and I can specify that as A dash and B dash. And this will be your apparent length, and this will be true inclination, and this will be true length. So this is about the fourth condition. Coming into fifth condition again, this will be parallel. So I want to incline with respect to HP. So this is the condition. So this inclination with respect to HP can be shown as theta. So here you can see, so when I want to observe from the top, I can't see the true length. So again, when I want to project, it will be reduced length. So this here, the top view becomes the apparent length and front view goes for the true length, because when I want to observe from the front, I can see what is the actual length of the line and what will be the actual inclination. So that will be projected over there, that is B dash and A dash. So an angle will be drawn. So when I want to project that, the projection line I want to join, that is the end projects of B dash and B, and again end projects of A and A dash and A, and I want to join. I want to get the actual view of the thing. So here again I want to start with the vertical line, that is the front view. So I want to draw the front view A dash B dash with the true inclination. Then I want to project A dash as well as B dash to B. Then by knowing the distance, I can join that A and B line to get the top view. So top view here it will be apparent length and here it will be the true length. So the fourth and fifth condition together can be termed as the sixth condition, where both the line will be inclined to both the reference planes. This is the condition. So here, whenever I want to observe from the front, I can't justify what is the true length. When I want to observe from this, I can't justify, because the line will be first parallel. I want to incline to HP, then again the same line I want to incline to VP like this. So both the sides it will be inclined. That is, this side also it will be inclined and this side also inclined. So this will be with respect to alpha and this will be with respect to beta with respect to the vertical plane. So this is the thing you want to get. So this, when I want to observe from the front, I want to get the view of that with the inclination. The inclination will be not exact inclination, because it is inclined to both the planes. So I going to term that as alpha. So alpha is called as apparent inclination. So which I explained in the first slide. These are the terms you have to remember. Again, when I want to project from the top, here also I won't get the true inclination. I want to get apparent inclination, that is beta, with respect to the vertical plane. So and the length also will be varied, and the true length will be different than the actual length, that is the actual view length. So here the what are the lengths I going to get? These two lengths are nothing but the apparent length. So the problems will be asked based on this, whether you have to find the apparent length or you have to find the true length when they given the front view and the top view. So I'll repeat the things. So the five conditions. The first condition, perpendicular to HP and parallel to VP. So there I going to get the true length and a point when I want to use that one. So next condition will be line perpendicular to VP and parallel to HP. Third condition, parallel to both VP and HP, where I going to get the true length from both the sides. And the fourth condition and fifth condition are the one which will be merged together to get the final condition. So when you're dealing with the final condition, remember that. So you have to assume first with respect to HP and you have to draw the projection. Then you have to draw the projection with respect to VP. Then you have to merge together to get the overall picture of a line when it is inclined to both HP and VP. So the problems on this condition will be explained in the later videos. So thank you guys.